Hey everyone. So we have a session here today with Rob Jenkins. He's going to talk about React Native and how you can use it to streamline your code, make more money, have less workers, live the dream. So I'm going to turn it over to him.
Hi, this is mobile development with React Native. Write code, get paid. Although the original title was Mobile Development, Professional Software Development, Stack Selection, and why React Native is just the best thing, or at least it is for me. That was a little too wordy apparently, so we're moving on from that. So the first part of this is going to be about professional software development, stack selection. And then I'll move into showing a little bit of React Native, how I develop with it, and why that works for me. It's not going to necessarily work for everybody, but hopefully there's something in here you can take away from it. A little bit about me. My formal education is in physics and applied mathematics. I've been in the IT industry for 25 years, probably 25 plus at this point. And I'm a self-taught programmer, so you're going to find that there are programmers, there are developers out there that do things in a much more formal way and a much more better way in some circumstances. Don't take anything I say as gospel. If you're learning in a formal, structured environment, listen to that. I've developed in C, C++, Python, PHP, now JavaScript, just about everything, Ruby. Trying to be a little bit flexible. Who this is for and who this would really apply to is if you're looking at software development as a profession, you want to get paid. If you've got a passion project, you want to work on some sort of obscure operating system with a weird language because that's something you're really into, that's great. Don't let any of this dissuade you from doing that. But if you want to do this for the purposes of employment or for contracting and making money, this might be applicable to you. In furtherance of writing code and getting paid, I've got 3 pieces of advice, hard-won pieces of advice. And number 1 is to maximize your target platforms. Number 2, minimize your pain as a developer. And number 3, be flexible and never get married. Now, maximizing your target platforms isn't always, it's not a hard rule. There's certainly been times in my career where you're working on one platform and you have to write some really close to the metal code. There was an unmanned naval vessel, unmanned surface vessel project for the Navy. I didn't do much coding on that. I did the wireless networks. Embedded projects, certainly you're going to be writing close to the metal. These things aren't going to apply 100% of the time, and certainly it hasn't for me. But in general, if you're writing software for building a product that you want the most people in the world to be able to use and to use easily, you want to find a way to maximize your target platforms with one code base or one code base and maybe a few changes to hit a couple extra platforms. So when I started with computers a million years ago, maximizing your platform was not a thing. Everybody I knew had a home computer, one of these 2. I had the one on the left there, which is obviously superior, but most of my friends had the one on the right. And anything that I wrote for mine could not run on theirs and vice versa. Everything was siloed, and you see that over and over in all kinds of industries, not just personal computers, but you'll see that in technology in general throughout your careers, that things start in silos and then technologies come along that disrupt that and bridge these silos. And that's really where opportunity lies for you. So even within that silo, the very first piece of commercial software that I wrote was a screen dump program for the color computer. And within that silo that I had, even within that, there were differences. I had the system on the left where you're computer code was actually stored on a cassette tape, believe it or not. And people that had a little bit more money had the floppy disks over on the side. And the memory layout between the two were not the same. So my software developed on the system on the left wouldn't run on the system on the right. And as a result, my would-be commercial code never saw the light of day. At the same time, things weren't going too well for video game systems either. They were siloed too. You know, the console wars were a thing. And developers that wanted to write and produce a game for one system would have to have a completely separate code base, a completely separate team of developers often to target a separate platform. AAA games, which pretty much weren't a thing for the most part, when they were developed and they were cross-platform, often they would have completely separate companies developing, say, ET or whatever back then for a different console. So things got better there. Like I said, technologies come along that bridge these silos all the time, and we see that with the commercial game engines today. Bridge these different platforms. A lot of times you can have one code base now. You can target multiple platforms. You can hit PC, you can hit mobile, and it made things a lot easier for game developers. Back in the personal computer realm, things were not so great. It was solidified into kind of PC and Mac camps. And I don't remember there being any real serious attempts to make a cross-platform software development experience for desktop users. It was just, you know, write code on one, it would run on one, write code on the other, it would run on the other, until the World Wide Web. When the web came along, everybody had a browser. That was the level playing field for everybody. But developing for the web wasn't very easy or very glamorous. Initially, we had this common gateway interface that you could get basic information from a web page, usually from a form, and then you would process that with some sort of interpreted language like Perl and generate maybe an email response for your forms, something like that. It was very, very primitive and very difficult to do anything of any use. After that came commercial CGI languages like Cold Fusion. I developed with that for a little bit. That was nice. It ran on Windows servers, allowed you to get meaningful information into and out of a database. You could start doing some web apps that way. PHP came along. It was great. It seemed a lot like C, but it was maybe a little bit messy at the beginning, and you had to do a lot of poking around with your web server to get it to actually run. Then Ruby on Rails. That was a really nice platform, allowed agile development, took away some of the pain points with working with clients who wanted big changes to their databases. For example, in the middle of a project, you could just run versions back, run things forward. Things started progressing quite a ways. But still, none of these really took care of that second point, which is minimizing your pain, because things were still very laborious. Things were very primitive still. So minimizing your pain as a developer, to me, means that there's an existing user base. There are lots of libraries around. This little comic from XKCD kind of exemplifies that. Python is great. Everybody loves Python because there's a module for everything. If you want to fly, just import fly. And there you go, or import anti-gravity is what it says here. But the way the wind was blowing, and seems to have settled out as far as a lot of web development is going, was JavaScript, which I would have never guessed in a million years, because I used to make fun of JavaScript developers. If you weren't writing in a compiled language that generated native code, what were you even doing? But all my friends that were doing front-end JavaScript development, they were really ahead of the game. And you see here the number of JavaScript modules available out there compared to even Python. It's just not even close. There's no close second when it comes to it. And a lot of this came from, I think, Google. When they were working on Chrome, they really updated the JavaScript engine in Chrome, and it was running a lot faster. It allowed people to do things like build Node.js. A lot of smart people put that together, and then you have developers that are actually using that and using JavaScript to develop the back end for web-based applications. So you're not at the mercy of Apache or IIS to handle the back end of your web app. So you've got a consistent language across the whole experience from the end user to back end. So that's the direction that I took. But talk about tyranny of choice. There are all kinds of jokes about JavaScript libraries. 2 JavaScript libraries walk into a library and 20 come out. When I was looking for a platform to really work with and develop web apps with, I thought, boy, which small, opinionated, elegant JavaScript framework for the web am I going to use? Because a new one comes out every week. Fortunately, after looking at a bunch of different things, and there were a bunch of different things I looked at, Angular was great, but they completely reinvented themselves between Angular 1 and Angular 2, apparently. So if I was going to relearn something, I'd just pick something else, maybe. I never got into Vue. There was a Sales.js framework that was almost exactly like Ruby on Rails, which was what I was used to at the time, but ultimately still found a little restrictive. What I did find and settle on, finally, was React.js. React.js is an open source project from our good friends at Facebook, and it allows you to build front-end user experiences in a declarative way. You build components. You structure your front end in modular pieces that you can reuse. And it looks like HTML tags. You're basically building your HTML tag. If you need a user profile section on your web app, you can build a user profile component and stick it in wherever you want in your layout. If you need a post feed for your social media app, you can build post feed component and stick it in wherever you want in your layout. So that kind of thing solved the fact that it did everything that I wanted as a framework, and it had a huge developer community behind it. Really solved the pain points for me as a developer. And I'm not saying that you just should follow the crowd necessarily, but you do want a large community of people contributing to a product and actively developing in it, so that when you run into a problem, you can be relatively sure that you're not the first person to ever run into that problem, and you can leverage the experience of people that have come before you and write more code and get paid instead of reinventing the wheel. I'm not saying that just because there's a large company behind React or anything else that you should follow that, or that it's automatically going to be successful, because sometimes it's not. So I have a friend, just to illustrate this point, I have a friend who has an MBA, and more than anything else, I think he would rather be a JavaScript developer. And he sends me things like this from CodePen all the time. It's like how to make a multi-step progress bar. And he sends this to me, and here's all your HTML, your CSS, your JavaScript that works with this. And you can step through a process in your web app. And that's great. And that's a lot of work. And he's learning a lot about JavaScript. And I would have done the same thing when I was much earlier in my career. But I would much rather just import a module, drop it into my app and use it and write the code and get paid. So React.js, solves those pain points for me as a developer and lets me generate more code. So there you go. Happy as a clam with my stack selection, and I can just ride off into the sunset. Except I have to be flexible and never get married to anything in particular, because everybody starts using these things. And since 2013, that's been the dominant way that people have gotten into the web. That's the dominant platform out there. So how can I be flexible and still leverage some of the things that I've learned with React? And that is with React Native. Thankfully, Facebook, regardless of what you think of them, is a very large platform, and they've run into these same problems. And they've open sourced their solution. And besides React, they were seeing the same thing. Everybody's moving to mobile. So they came up with React Native, these little extensions to React, because you do use React with React Native. But you'll see that there are little changes. You still have a component lifecycle, just like you would. Your apps are structured relatively similarly, but little changes, like your layout. The div is now a view. Your spans that you would use in your web app are now text. Images are just spelled out. Some things library related. On the web app side of things with React, you might use Material UI or something like that to give your app a consistent look and feel across all the pages. Native Base takes care of a similar problem in React Native. I'll show you a little bit of that in a minute. For routing between your pages, React Router is a popular library in React. React Navigation, open sourced by Wix, is probably the dominant routing solution for React Native. Some things stay the same. You can still do state management with Redux. You can still pull in things from APIs with Fetch. You can use the Apollo GraphQL client. I've certainly done that. Your form libraries, Formic and React Hook Form, still work across each one. So I've talked a lot about that. So how about I show you how React Native takes care of some of those things and what the workflow kind of is. So Expo, I know we've been talking about React Native, and all of a sudden I say Expo. Expo is kind of a framework for working with React Native. It takes care of a lot of the pain associated with even building React Native applications. Expo was built by a couple of Facebook employees who thought, React Native is pretty awesome, but the actual process of building and deploying an app with React Native, we can automate that a little bit. So they built Expo. Expo is basically an API that you, and a set of tools, a tool chain that you build and develop your React Native app with. And then using their platform, you can hit hardware features across between Android and iOS with one code base. You use their components, and you don't have to do this hitting the metal, trying to decide what platform you're on, whether you're on an Android phone or something from Apple. You just use accelerometer and you have access to the hardware. You use your barcode scanner. You can get hardware information from the battery, things like that. Using the camera is a big one. Even if you go to the React Native website and you look at getting started, I want to run a Hello World application, the native command line interface is right there with Expo. They recommend Expo because those two guys from Facebook that developed this, after it became successful, got a call from Facebook, and long story short, Facebook bought them and they work for Facebook again. So start your application with Expo, build with Expo. The trade-off between that and the native command line is that your bundle that you build is a little bit bigger, but that's probably about it. So let me show you an example. If you're going to build an app, with Expo, you would ExpoNet app name. And then it's going to ask you some boilerplate questions. If you want a blank app, if you want, what do you want to call it? If you haven't provided a name, do you want to use a template, that kind of thing. And I've already done that here. So we can look at this test app. You can see that it builds a basic application for you. Over here, there's some things that Expo uses, your assets for images, things like that, app.js and app.json. So, and your package.json. Here are going to be some basic things like the name of the app. All of this should look fairly, these things should look fairly familiar to you if you're familiar with React. So once you've built your app, you can start it. And Expo will launch and give you this convenient developer dashboard right here in your browser. It takes a second. It builds the, it'll build a JavaScript bundle of the app that you have. It will communicate with any Expo client on your network. In this case, I have the iOS simulator running already. So I can click Run on iOS simulator. And depending on whether the iOS simulator is awake or not, you'll get your app running in a simulator. This will work also with the Android emulator if your laptop happens to be beefy enough to run Android Studio along with Xcode's simulator. You can do that, and it'll certainly push out your app to the simulator here, to either one, whichever one. And since the whole point of doing this is a cross-platform exercise, you'd probably want to do that. Also, instead of just working with emulators on your machine or on other machines on the network, you'll notice this QR code over here. There is an Expo client for Android and for iOS that you can download out of the App Store or the Play Store onto your physical device. When you open that up, you'll have the opportunity to scan a QR code. And if you're on the same network, your same local network, it will pull that JavaScript bundle across onto your physical device. And you can see what your app looks like on the physical device, test and troubleshoot while you're developing on a physical device as well as an emulator. And it doesn't look like the emulator's too happy right now. Let's see. Let's try that. We may be pushing my laptop to the extreme of what it's capable of doing. I'm afraid that's probably what's going on here. We're streaming from it and asking it to do all kinds of things. So, oh, here we go. Maybe. Yeah, it's just now restarting. So I'd say it's under quite a bit of load. While that's doing whatever that is that's going to do. Also, in the name of cross-platform, cross-platformization, is that? No. I mentioned native base just a little bit ago. Even though you can use a single code base to target iOS and Android, those two platforms look completely different. There's the Cupertino layout. Is that what it's called, Patrick? And then obviously Google's icon set and everything's different. So you wind up doing a lot of, again, detecting which platform you have and then applying styling differently to target a different platform. So you have two different style code bases within your project, and that's no good. So native base fills in that gap. Native base, where in React Native, you can pull in a button from React Native, you can pull in a button from Expo, or you can pull in a button and other UI elements from an external library like native base. Native base does that checking for you, and it displays an Apple themed button if it's on an Apple platform and an Android themed button if you're on a Android platform. And it does this automatically. You just drop in the component. It saves a lot of time, and it makes your apps look not like they were developed with some Frankenstein framework that's not native. It gives you that native experience that both Apple and Google have spent so much money developing. Let's see here. Yeah, we're overtaxing everything, it looks like, including the browser. Wow. So if you go to docs.nativebase.io, you can actually go through all of their components and look at on their webpage how they would render on each platform. You go to, let's see, if you go down to something like, here we go. Icons, you can flip back and forth between iOS and Android and see what that particular component would render out to on each platform. Here we go, buttons, super fancy, but there you go. Badges, themed buttons, and it takes care of this cross-platform UI experience for you. So probably doing your first applications with React Native, I would recommend using this. Save yourself a lot of time so that you can write code faster and get paid for it instead of spending a lot of time trying to, looks like, okay. So it looks like we did get our application, despite this error. Looks like we did get our application opened in the emulator. If you go to your code, you can see that you make a change here. Hopefully, yep, it refreshes automatically. You get hot reloading. All of this should look pretty familiar to people. One of the things that looks different here is the style sheet convention. You build these style sheet objects that reference your styling right there in your code, and then you apply those things. Layouts accomplished by Flexbox model. So if you're using Flexbox for your layouts, you're already a step ahead. And like I said, this is just a boilerplate application. Let me open a more fleshed out app. And we won't run the simulator, we'll just look at the code. This is a social networking application that I wrote in React Native, and it uses, look here, amazingly, there are things that you have to do to jump through hoops to get things to work, and sometimes it's not great. And I have a lot of log calls in here still to help me with debugging, troubleshooting little things. But what I want to show you is kind of the layout. Like I said before, you compose everything, your layout, your screens and everything with components. I have components for buttons. I have components for login forms, any kind of form, any kind of feed. For example, here's a post feed. This is GraphQL here. I'm just describing the information I want to get from the back end. I'm describing it as a JSON object, and I push that out, get all that information back in one round trip. It's really kind of nice. And then we're building post feed, which is this component. We have what it returns, we have the styling, and that's exported. So on my main screen where that's displayed, because your screens are also components, you just tell your routing that this route equals this component, and that component is a screen. And that screen can contain all kinds of UI components. So, so you can follow what this returns. This is just a screen that returns one container. It's got a safe area at the top for the header. It's got your left button, your center, body, the right menu, some icons for doing searches and things like that. Here's your button, on press, navigate. It's that simple, that straightforward. You can follow this code. And here's your post feed. That was the component that we referenced just a minute ago. And that pulls up, has its own life cycle, pulls in all that data and everything, and your footer. So this is a more fleshed out example of what you're going to actually build with it. But everything's a component. Using Expo, I can build to a Android target, to an iOS target, and even to a web target. It looks a little funny because it's trying to stretch it to whatever width your browser is, but it will do it. I think behind the scenes it might use Expo for web or something like that, but the point is, or React for web, or whatever that's called. But the point is, I don't have to know that. I can quickly stand up something that targets Android, iOS, and web all from one code base. Personally, I prefer to keep the web app as a separate entity, but I can leverage a lot of the code that I've developed for the mobile side for the web app. I can pull the stuff here off the GraphQL calls. All of those things are the same. I just use the same library and use the same code for pulling the stuff in. So this really minimizes my pain while maximizing the target platforms that I'm aiming for. And just before I completely go here, I want to show you the server code. I have that here in the same folder. All of the server code is also built in JavaScript. It's not, it's modern JavaScript, and I'm not using components or anything, obviously, but you don't have to shift gears. You can stay in that mindset of writing JavaScript code and run your backend too. So, I'm using resolvers in my schema here for GraphQL calls, and it was quick to stand up an API for this application. So this really works for me. This is what I use, and this is what I'm happy with for the time being, at least. But I'll keep in mind my own advice to stay flexible and not stay married to any particular platform, because 5 years from now, somebody could be doing something much better than this, and it behooves you to stay flexible and move where the target goes. So that's it. If anybody has any questions, be happy to answer them even after this. GraphQL is another one of those technologies that Facebook developed and then open sourced, and the rest of us can benefit from that. I really don't want to sound like I'm a Facebook cheerleader here, but regardless of what you think of them, they're a giant platform that have hit all these scaling problems that all of us would, aspire to hit with our products, but they've hit these problems first. They've solved them in creative ways, and then they've open sourced the solutions. And GraphQL is an example of that. So in your normal REST environment, REST API, say I have a social media app and I'm pulling in, like I did there in this app, I wanted to get my users. I get the user it's logged in. I want to get all the posts that would be applicable to that user. I want to get information for each of those posts. I want to get maybe a picture. I want to get number of likes, dislikes, or whatever. I want to get comments. The comment is linked to another user. I want to pull in at least the first name and last name of that user so that I can display all this in the UI. So you're either making a lot of round trips back and forth to your back end, or you're doing a lot of crazy joins. And, and then if your UI changes, all of a sudden I don't really need all that. I'm just doing it in a more condensed form. Then I've got to change the API on the back end. So then I'm stacking versions of my REST API, and I'm hitting shelfbearer.com API v1, v2, whatever, and I'm trying to support all these based on who out there is upgraded and who hasn't. Well, Facebook hit this too, and their problem was exacerbated by the fact that mobile was just coming of age, and we have, especially when mobile was just starting, you don't have a good connection all the time. So you can't be relying on all these round trips back and forth to the server from your mobile client. And they tried doing these embedded or wrapped web apps for mobile too, but it didn't work. So what they came up with was GraphQL. And here's what you do in GraphQL instead. In GraphQL, you say, okay, I want posts. I want to get the ID, the title, location, posted at. Here, I want the creator, which could be in a separate thing. I want to grab this information about the creator. I want to get comments. I just want to get the IDs for the comments, number of likes and dislikes. I can pull that in. You describe the information that you want from the back end, from your database, from your data source or sources as a JSON object. Send that one JSON object off to the back end, and what you get is a JSON object that looks exactly like what you requested. It'll be an array of these that you can loop through in your UI. If you decide that you want different information, you change the JSON object and send it off to the server, and the server, through these resolvers on the back end, which grab these different requests, and they fill in the information, and they can pull that from not just one data source, but they can pull it from multiple data sources, different types of things. You could pull stuff in from a SQL data source. You can pull things in from something like Mongo, some sort of NodeDB kind of thing, and merge those together, push them out, and it's a pretty seamless experience on the front end. And as a developer, especially for mobile apps, it gives you a lot of flexibility. So. All you're getting back, all I was requesting back in that example was I just wanted the IDs of them so that I could use that later or just count them. But what really counts is let me pull it up here again. What really counts is just that creator object. You don't need the foreign key. It knows that there is a creator, and on the back end, it knows that that's in a user table. It's just called creator in the post definition in the schema. On the server side, you do have models, you do have you do have keys and stuff like that, but that's not required on the. that is the foreign key. That is how the database keeps track of it on the back end. But on the front end, that's not something you ever have to touch, ever. And if you're on a sketchy mobile, connection, maybe you don't get that second call, and then your UI is left half rendered or it crashes because you didn't get all the information that you needed. There are tons of YouTube channels devoted to taking you through from ground zero all the way out to developing your first React JS applications. And if you're somebody locally, obviously there's the UForce Academy up there. Yeah, I mean that is a great resource here locally if you want to have that kind of instructor-led, hands-on thing. But yeah, especially if you have a background in JavaScript, it's gonna help. It's gonna be easy. JavaScript has changed a lot, but it's changed for the better. It's just the iteration of the language that I've seen in my JavaScript experience, everything's just made it easier for the user. We've gotten away from having these nested callback hell indented messes to using promises. Just everything has made it easier for a developer. At no point have I looked at that and looked at a change and said, oh my gosh, this just complicates things. It's really, really the opposite. Wow, I looked at that a long time ago. It was kind of a wrapped thing. It wrapped your application in a web component and just ran a web component in a mobile thing. This is really light years beyond that. This generates, if you get into this and you get your own Expo account, when you do your build with Expo, it pushes it out to their servers. Their servers will manage the build process for you. They'll manage the signing keys and all that kind of stuff that you're going to have to go through to push things out to the app stores. And what you get back is an APK or whatever the equivalent is in Macworld. You get back a bundle that you just push up to the app store. That's the same kind of thing that you would get if you developed your app natively in Xcode, or you developed it natively with Android Studio and then compiled it. It's not some wrappered thing. I mean, it's under the hood, who knows what it's done, but it's not as blatantly wrappered as PhoneGap was. Performance-wise, I'm not sure what that would do. If you're developing a software as a service kind of business model, and you're putting out a mobile app client for your platform, increasingly, Apple is saying, and Google too, apparently, are saying, hey, you need to have a way for them to buy that service in the app, and then we want a third, or whatever highway robbery they're shooting for there. So the future might be, in the face of that kind of thing, is pushing back to strict React JS and making a progressive web app so that you have a shortcut on your phone, but you're running a web app and you're persisting some data there. That may be the short-term future for that kind of thing. Yeah, Apple's doing everything they can to keep progressive web apps from flourishing because of exactly that, because you can circumvent that buy requirement for the store. Yeah. Initially, there were certain things, I think, when I was first learning about Expo, there were certain things in it that, oh, this isn't going to fly on the App Store, and they had to work really hard to get around that. But from what I understand, they've gotten past those hurdles. And there are some big companies using. You can look it up. There are some big companies using Expo to build their apps, because you can build it quickly and get a product out there, write code, get paid, you know. I'm working on that Shelf Bear app for finding.
About the TP.
Yeah, that was concerned, particularly in March, and it may be again. But you can follow along on that at shelfbear.com if anybody wants to. That's my little fun quarantine project. But yeah, that's it. Thanks for having me. I appreciate it.
Thank you very much.